Alright, so for 64, it's a square root of 81b to the fourth. So you can write it like this. You can write it as 81 to the 1/2 times b to the 4 over 2. And so 81 to the 1/2, the square root of 81 is 9. And b to the 4 over 2 is b squared. And that's all. For 65, the index is 4. So you can write it as 4th root of 256 times z to the 16 over 4. So I wrote it differently just so you could see that you could do that. You can, write one with a radical and one with a rational exponent. Now the 4th root of 256 is 4, because 4 times 4 times 4 times 4, 4 to the 4th power is 256, and this is what I'm saying, that it's 4 to the 4th, like that. And this is z to the 4th, because 16 over 4 is 4. So the answer, this 4 here, comes out of the radical because I have 4 of them, and there's nothing left inside, so it's just 4 z to the 4th. For 66, the first thing I'm going to do is I'm going to reduce the b's because I have a b in the denominator and b to the 5th in the numerator, so that, cancel that one, and then that becomes a 4. So I have square root of b to the 4th over 49. So the square root of b to the 4th is b squared, and the square root of 49 is 7, and that's all. For number 67, for the first factor, I'm going to distribute this 4 to both of them, both here and here. So that becomes a to the 6 times 4 is 24, and then b to the 1/2 times 4 is 2. And then this one, the b comes out completely, right? Because there's 3 b's and it's a cube root, so it just comes out as a b. So then I have a to the 24 times b cubed, because I've got 1 here and 2 here, so that's b cubed, and that's the final answer right there. For 68, solve it. I have to get rid of the radical to solve for x, so I'm going to square both sides. So that leaves me with x minus 5 equals 16, so I'm going to add 5. So that's x is 21. And just quickly do a check, put a 21 in there. 21 minus 5 is 16. Square root of 16 is 4, and it works. For 69, it's raised to the 1/3 power, so I'm going to cube both sides. Oops, change the color by accident. Cube both sides. And so on the left side, 3 times 1/3 is 1, so this cancels. And so I'm left with x minus 8. On the right side, 8 to the 3rd power, that gives you 512. 8 times 8 times 8. So now we're going to add 8 to both sides. So that gives you x equals 520. For the number 70, we're going to cube both sides, so I put a 3 here, and then don't forget parentheses, 3. So remember, this side means x minus 2 times x minus 2 times x minus 2, 3 times. So you multiply 2 at a time. So this is, let's bring down the first one, x squared minus 4x plus 4. And then you multiply this again. You could either make like a little 2 by 3. And so x minus 2, x squared, squared, minus 4x and 4. So this is x cubed minus 4x squared, 4x, negative 2x squared, 8x, 8x, and negative 8. So we have, on the left side, we have 7x plus 22. On the right side, we have x cubed minus 6x squared plus 12x minus 8. So I'm going to subtract 7x and subtract 22 from both sides. So that gives me 0 on the left side. X cubed minus 6x squared plus 5x minus 30. And so we have to factor that and factor by grouping. So when I factor by grouping, I just do a 2 by 2 and put the terms inside. X cubed minus 6x squared, 5x. And if it doesn't factor by grouping, then we have to do the p's over q's. Okay? So I always check factor by grouping first. So greatest common factor on the top row is x squared, and then x times x squared, negative 6 times x squared, and then 5 right here, and it works. Okay, so my two factors are x squared plus 5 and x minus 6. Okay, so for the first one, you said each one equal to 0, right? So x squared plus 5 equals 0, and x minus 6 equals 0. So the first one is x squared equals negative 5, right? Because you move the 5 over. Take the square root, and you always do plus or minus. So x is plus or minus the square root of 5i, because there's a negative inside the radical. And for the second one, x equals 6. So the two the three values are plus or minus square root of 5i, and then 6. For 71, we're going to square both sides to get rid of the radical and the 1/2 power. So don't forget, you have to square the whole thing. So I'm going to put parentheses around this, and then like that. Okay? So on the left side, this 2 is outside, so you have to square it. So 2 times 2 is 4. And then what's inside the radical just comes out. So I'm going to put parentheses around it like that. On the right side, 1/2 times 2. This cancels with this, so I'm just left with 6x plus 2. So now I have 16x minus 4, because you've got to distribute the 4 to both of them, equals 6x plus 2. I'm going to subtract 6x and add 4. Cancel, cancel. So 10x equals 6. I'm going to divide by 10. And so x equals 3 over 5 when you reduce it. Number 72, you think, okay, I'm going to square both sides. The problem is you have a negative on the right side. So this one's like no solution right away. Okay, no solution. Because you can't square it. Well, let's try it so you could see. When you square, you get x plus 6 equals 64, right? Because negative 8 times negative 8 is 64. And then you subtract 6. I just want to show you how algebraically you get no solution. So x is 58, right? So when you plug it back into the original, it says 58 plus 6 equals negative 8. Well, this is 64, and this is actually positive 8. So positive 8 does not equal negative 8. Okay, so this is no solution. And you knew just by looking at it, because you have a negative on the right side, but it's no solution. Number 73, we are going to first move the 2 over to the other side. So now I have the 3x minus 5 to the 1/3 power equals 7. So 3x minus 5 to the 1/3 equals 7. I'm going to cube both sides like that. So I'm left with 3x minus 5 on the left side, because 1/3 times 3 is 1, so this cancels. And then on the right side, 7 times 7 times 7 is 343. So we're going to add 5. So 3x is 348. Divide by 3. So x is 16? Yeah, 1/16. Here's the answer.